Easy Join is a new advanced capability added in NX 2306. So if we go into that command, I'm going to start by demonstrating it with just two components, and then we'll go in and look at joining the rest of the components in this assembly. So for starters, I'll just take these two parts, and basically what we want Easy Join to do is figure out if I want to put these two parts together, where should the points be placed in order to get the optimal design. Now, we do have several settings that would help determine where those point joints are going to go. So we're looking at, first of all, how do we generate the overlap areas, basically looking for flanges that are going to go together. Then we have some rules that go into determining how the guide curve should be formed. Typically, they're going to be done on using a centerline methodology where we go down the middle of the flange. And then finally, we have point layout settings that basically will affect the spacing of the points along those guide curves. Now, in the most simple case, I simply select the two components I want to join. I run the preview. You can see it figures out that where those areas are going to be. I can choose the type that I want, and if I just click OK, you can see as a result I'm going to get spot welds placed in all those locations. These are all going to accept default values since I didn't go through the dialog. I simply said go generate spot welds wherever the algorithm came up with them. And so that's a really quick way of getting these placed in the appropriate locations for this particular set of components. So let's look at a more complex example. We'll go back into Easy Join. And this time, we're going to select the remaining components in our assembly. So we'll take these 4. And we'll go ahead and run the same preview. You can see it's generating those overlap areas, guide curves, spacing out the points along those curves. And then we divide things into areas where we have 2-part stack-ups and then areas where we have 3 sheets in the stack. So if we're interested in taking a look, for example, at these 3-part areas, if I have this option for center on selection and I select one, you can see that those will be highlighted. You can see here that we've got an area where it looks like the gray part comes in between the green and the yellow ones. And then we've got another similar region on the other side, same thing. In this particular area, we've got a 3-part stack. Everywhere else it's 2. Now for this particular assembly, the way I'd like to assemble it is in the 3-part areas, we want to go ahead and use spot welds. So I'll go ahead and go into a dialog, and rather than just clicking OK, this brings me in here where I can decide, okay, what do I want my spot welds to look like? So instead of just accepting default values, I can choose how I want them represented. So maybe I'll choose cylinders, or I can choose spheres. I can choose an appropriate size. And then finally, I can decide what color I want those to show up as. So we'll go ahead and create spot welds at those areas. Now, everywhere else where I have the 2-part joins, we want to create mechanical clinches. So here, once again, I'll go in. Instead of spot weld, we're going to choose mechanical clinch for our type. You'll notice that the preview will be updated for that type. And the default behavior is whenever we have mechanical clinch, we want to see a green cylinder. This is controlled by another settings file that determines for the clinch what it should be represented as. But because these are all in the 2-part areas, it's always going to be a green cylinder. When we have 3-part areas, that would be represented as a triangular prism. I can choose the diameter that I want to see there. We'll make these 8 millimeters. OK. And you can see that as a result, I was very rapidly able to create a large set of these join features. You can see we've got some spot welds here represented with the spheres. We've got other spot welds here represented with purple cylinders. And then finally, we've got our clinches, which are quite obvious with the green cylinders throughout the model. Now, if we were to look at any particular area and want to make some changes, so for example, if I wanted to take this whole set of clinches along this area and move them maybe to a different location. So maybe instead of using a center line, I want to switch over to an edge offset. I can select one of those. and we can traverse and see that, okay, this mechanical clinch was built from a point layout, which then was generated off of an overlap curve. So let's go ahead and modify that overlap curve feature. And what I'm going to do is I'm going to switch to an edge offset. So here I'll go ahead and say, all right, well, I want to use this edge here. I determine what the value is that I want. So we're going to make that 8 millimeters. And you can see that when we do that now, because we have all of that geometry, it was very easy for me to take that entire set and move them a little bit closer to the edge because I didn't want to use the standard center line. So really the power of this is that we'll lay out the initial set of points, create the join features at those locations, but then it's very easy to go and start to tailor those to represent what you want in your design.